Hey, hello everyone. Welcome from RushiTechnologies. Today is just the demo session of DevOps with AWS and Terraform course. Before we start the demo and before we start the agenda of today, first let me introduce myself. Most of you guys know me by name, but let me officially introduce myself. So myself, Balaji Reddy, Lachanagari, having 16 plus years of experience in IT, and I started my career as a developer in 2009 as a Java developer, and initially for a couple of years I was working on completely development side, and in early 2014, I got an opportunity to work on DevOps as well. So since the last almost 12 years, right, I am into development as well as DevOps, and I got an opportunity to work with various service-based companies, various product-based companies. During my experience in all these companies, I got an opportunity to work with DevOps and cloud solutions. And I have specialized in cloud platforms like AWS, Azure, GCP as well, and also various DevOps tools like Docker, Kubernetes, Terraform, Jenkins, ArgoCD, GitHub Actions, Helm, Prometheus, Grafana. Throughout my career, I had the privilege of mentoring and guiding more than 10,000 plus IT professionals and students. And I am into training for almost the last 9 years. And I trained across the globe. We have students. So this is about myself. And before I start the agenda for today, let me give you the course details. This is actually morning batch, DevOps, DevSecOps, security related tools also we will be covering here. DevSecOps with AWS Terraform course. The regular classes will start from August 3rd, that is Monday. It's a morning batch. The class timings will be 6:30 a.m. Here there is a typo. 6:30 a.m. to 8:15 a.m. IST. The demo is evening today, but the regular class timings will be morning 6:30 a.m. to 8:15 a.m. IST. The course duration, as you guys already know, we are going to cover from very basics to full advanced level of DevSecOps tools with AWS and Terraform. So it will take around 6.5 months of duration, and extensively it will take around 200 plus hours of training, more than 200 plus hours of training. So this is about myself and the course timings. Let's get into today's agenda. In today's session, we'll just focus on what is DevOps and why DevOps and DevOps principles. DevOps principles, and also we'll try to understand about SDLC, software development lifecycle, and here we'll try to understand about waterfall model, and we'll try to understand about agile model. So here, first, let me give you the definition of DevOps. What is actually DevOps? So DevOps here, it is not a tool, it is not a technology, it is not a programmatic language. So people may think DevOps is one tool, one software. People may think DevOps is one programmatic language, or people may think DevOps is one kind of a technology or a software. So actually DevOps is not a tool, DevOps is not a technology, DevOps is not a programmatic language. Basically, DevOps, it's a set of practices. DevOps is one kind of a culture. You can think DevOps is a culture. It's one kind of a culture or a methodology. DevOps is one kind of a methodology or a culture. DevOps is a culture or methodology, and set of practices. DevOps is a culture or a methodology. It's a set of practices. It's a set of practices and tools. Set of practices and tools. Set of practices and tools used by development team, and operations team. Used by development team and operations team to build, test, release, and maintain softwares, or maintain applications or softwares, we call it, quickly, efficiently. So basically, DevOps is not a tool, DevOps is not a technology, DevOps is not a programmatic language. Basically, it is one culture. It's a set of practices and tools that is used to deliver the applications or a software quickly with high quality. So DevOps is used to reduce. DevOps is used to reduce the application development and delivery. Using DevOps tools, using DevOps methodology or DevOps tools, we can reduce the amount of time that is taken to build, deploy, test, and release the applications. But before we get into DevOps, first before we get into DevOps, first understand why DevOps is actually required. So before understanding DevOps, let's understand why DevOps came into picture. Why DevOps came into picture? Suppose you imagine, right? You wanted to order some product from Flipkart, or maybe you wanted to order some product from maybe Amazon, or maybe you wanted to order food from any food application, right? What you expect basically, you will expect fast delivery. Whatever, let's imagine you wanted to order food from Swiggy or Zomato, or maybe you are ordering some product in e-commerce platform. So you as a user, you will expect a fast delivery, and again good quality. The quality of the product also will be it should be very good, and there should no delay, and you wanted to track, you wanted to do the real time tracking. Similarly, suppose some company, some organization, or some company wanted to develop some software, some application. Some company or some organization wanted to develop some application or software. The software customers also will expect something in the application. So The software customers means, let's imagine there is one company, like let's take maybe some banking sector. Maybe you take maybe SBI Bank as a company, or as a banking organization. They wanted to develop some software to their customers. Maybe they wanted to bring some kind of an application to their customers, using that they can check the statement balance, they can do the fund transfer, they can add payees, delete payee. So as a software customers, they will also expect something in the application. So they will expect what any application or any software is expected to be having very less bugs. So software customers software customers expects new very less bugs, few bugs in the application. And also that application should be highly available, high availability. That application should be highly available 24 bar 7. That application should be available and accessible to their customers. And again, we should have a better security also, better security, data security, network security. And again, faster releases faster releases of new features. The new features of that application should be quickly released. So here, if you take any application or a software, so that software or application should have a very less bugs in the application and better security. The releases of the new features should be released very quickly. So here, in olden days, I mean to say, if you take 20 years ago, 15 years ago, the software releases happened every 6 months or every 12 months, like that. Suppose if you go back in the early days of IT, in 2005 2010 time, right? So people used to develop the application and the releases used to happen every 6 months or 12 months. So but the customers, I mean to say, the software customers are expecting faster releases, and that application should have very less bugs, and we should get the feedback from the customers also very fast. But 15 years back, 20 years back, the software releases used to happen every 6 months, 12 months. But today, if you take any application, you take Netflix application, they release thousands of changes every day. You take Flipkart, you take Amazon, you take Ola, Uber. So they are deploying the applications and they are releasing the new features continuously. And again, if you take Google updates many services daily. But how this is possible now? In 15 years back, 20 years back, the application used to be developed and delivered every 6 months, not very frequently. And again, whatever applications has been deployed, they used to have a lot of bugs, and we used to get the feedback very late, 15 years back, 20 years back. But if you take today, so many applications you take, like Netflix releases thousands of changes every day, and Amazon, Flipkart, Ola, Uber, they will deploy the new modules or new features continuously without any downtime also, right? So this change is possible because of DevOps. This change is possible because of the DevOps. So now let's understand what exactly is DevOps. So as I already said, DevOps is a culture, it's one methodology or a strategy where multiple teams, multiple teams like a development team, operations team, testing team, multiple teams collaboratively working together in order to build, in order to test, in order to release, in order to maintain the application quickly, and again with automation, right? So here, DevOps is bringing the development team and operations team together to build, test, release, and maintain the applications quickly, efficiently through collaboration and automation. So here, before DevOps, so before DevOps, right? I mean, sir, before DevOps came into the picture. So this DevOps became more popular from early 2012. So early 2012, 2011. So this DevOps became more popular, and so many projects, so many application teams started following this DevOps methodology. So here, before DevOps, the developers develop the code. The developers used to develop the code. They will write the code. They will provide, or they will give that code. They will give that code to operations team. Operations team, we used to call them as a build and release team. Build and release team. So here, before DevOps came into the picture, the developers used to write the code. They will give that code to the operations team. So here, before DevOps, developers responsibility is very less. The developers responsibility and accountability is they just need to write the code, and they will just hand over the code. But before they hand over that code to the operations team, they may deploy that application, they may deploy that code in their local laptop or a local desktop. Maybe there it may work. So the developers will write the code. They will first run that code in their local laptop or a desktop. Maybe there it may work. After that, they will give that code to the operations team. That operations team are a build and release team. So that operations team response is that operations teams, what they will do, they will take that code, and they will deploy that code in dev, QA, prod environments, production environments. So here, they used to take the code, deploy that code in dev, QA, production environment. Maybe when they are deploying the same code in dev, QA, staging, or production manually, they used to manually deploy or release that code by installing required softwares and configuration. They used to manually deploy. But the problem here is maybe it may not work on that servers. And again, when the testing team try to test, there might be a lot of bugs or defects. Maybe testing team may say, I tested that application yesterday, it was working, today it is not working. And again, when the same information is updated to the development team may say, that code is working in my laptop. So here, everyone is going to blame each other. Everyone used to blame each other. Developer will say, I have written the code properly, I have deployed that code locally in my laptop, it is working fine. Operations team will take the code and deploy the code in some servers. Maybe dev, it is working. When the testing team is testing in QA, it might not be working. So here, everyone will blame each other. So this is going to create a lot of delay in the production release, lot of frustrations, and the customers are unhappy here. So here, DevOps will remove all these gaps. Or silos. Here, it is not like everyone is working independently in DevOps. Suppose if people started using DevOps methodologies or DevOps culture, it is not like every team is working independently. So here, all the teams has to work together collaboratively, and with automation also. So here, development team, operations team, QA team, everyone is going to work together. Here. So here, with the help of automation. So here, development team will write the code. Again, whatever code the development team is returning, again, that operations team will take that code automatically, not manually, using lot of DevOps tools and DevOps practices. There will be automation. There will be automation. So now, in olden days, it is a lot of manual installations, manual configurations, manual deployments. But when people started using DevOps here, so in this DevOps, right, the the primary purpose of the DevOps is in order to build the applications very faster. So the DevOps, the main aim of DevOps. So why DevOps basically? So here DevOps is basically build software faster, build software faster, and again deploy automatically, not manually. Deploy automatically without any manual intervention. Whenever, whenever there is a change in the code, in DevOps, we have some concepts like continuous integration, continuous deployment, continuous delivery, continuous testing, continuous monitoring. So we will discuss about all those things in a regular session. But understand why DevOps. DevOps is required actually to build the softwares faster and deploy automatically. And again, whatever is deployed, we need to monitor. We need to monitor continuously. Monitor that applications and the servers continuously. Here, so the primary goal of the primary goal of the DevOps here is, right? The primary goal of the DevOps, faster delivery, better collaboration, more automation. We need to deliver the applications or a softwares faster, and again more automation. There is no manual intervention, more automation we need to do. Automatically taking the code, building the code, deploying the code, testing the code, automation. Everywhere is automation is required. So here in DevOps, right, we have so many tools, so many technologies they are going to use together. So here DevOps focuses on process, right? Automation process instead of manual process. Everywhere automation is going to be used here for building the code, deploying the code, testing the code. Also, automation is required. So DevOps primarily focuses on the process and the technology. Right? So here we have some principles in the DevOps principles. So collaboration. Collaboration is required in DevOps. Collaboration means working together. Collaboration. So here, developers and operations team. Operations team like a DevOps team. We call it as a DevOps team, CI/CD team, whatever it is. These developers and operations team will work together. They will work together here. Collaboration. And again, automation. Automation. So here, whatever manually we are going to do, whenever there is a change in the code, instead of manually taking the code, manually compiling the code, manually creating an application package and deploying that package in some servers like dev servers, QA servers, production servers, that manual work becomes automated here. We will do the automation. We will do the automation. And again, we will get the feedback, continuous feedback also. So every change done by the development team, immediately we can deploy that application in lower environments and we can get the feedback about that software, whether that application has any defects, any bugs. So here the feedback, continuous feedback. So the issues, application issues will immediately reach the developers. And again, monitoring. And also we will be continuously monitoring the applications and servers where the applications are running here. So here we have collaboration, automation, continuous feedback, continuous monitoring, like that. This is the DevOps principles. So here, if we are using this DevOps methodology, if you are using this DevOps methodology or a DevOps culture, so the advantages of DevOps here is faster releases. As I already said, faster releases. So traditional way, if you are manually deploying the application, we used to release application every 6 months. But if you are using DevOps, you can do the releases even every day also. You can do the release of your application even every day, faster releases. And again, here better collaboration, again better collaboration. Here everyone will work together. So developer will develop the code, and operations team immediately will automatically will take the code and deploy the code, and the testing team will test the code via automation. Immediately there will be a feedback about bugs, so immediately developers also can start working on the bugs. Better collaboration, everyone working together here. And again, automation, main automation. So earlier suppose you wanted to install some application or a software, so you need to create the server, you need to install middleware softwares like Java, Tomcat manually, take the code, deploy the code manually. But now everything is automated, right? You can automate continuous integrations, continuous deployments, continuous testing also by writing pipelines, CI/CD pipelines. We'll discuss about the CI/CD pipelines using Jenkins, CI/CD pipelines using GitHub Actions, like that. And again, here we will reduce the human errors. Here we will reduce the human errors. If we are using DevOps methodology or a DevOps culture, we can reduce the human errors. So when we are manually doing the deployment, maybe wrong version of the software is installed, wrong version of the file is copied, like that. But when we are using DevOps with automation, this automation will reduce the human mistakes or human errors, and we can deliver the high quality software or high quality product. And again, we can implement continuous testing also. Every code every code whenever there is a change in the code, right? Every code, whenever there is a change in the code and committed by the developers, for every change we can execute unit test cases, you can execute integration test cases, you can check the code quality, code coverage. If everything looks good, you can do the deployments again via automation. So here, continuous testing, better security, and availability, all these are like a advantages or features of a DevOps culture or a DevOps methodology. So here, DevOps is not a single tool. DevOps is not a single technology. It's basically, it's a set of tools and a set of practices used to build, test, deploy, maintain, and manage the applications. But we will discuss about various tools used in the DevOps methodology or a DevOps culture. But before that, we'll try to understand about SDLC. So this SDLC, what is SDLC, right? And with respect to SDLC, what is a waterfall model, what is agile model? After that, we'll try to understand the DevOps workflow and the DevOps flow. Here, various tools will be used together for automation. We'll try to understand. But before I jump into SDLC, I hope everyone is clear what exactly DevOps. So many people might be thinking DevOps is one programmatic language like Java, DevOps is like one programmatic language like Python, or maybe DevOps is one software, like that. So it is not a tool, it's not a software. It is one kind of a strategy, one kind of an approach where various tools will be used together by development team and operations team collaboratively to build, test, release, maintain, or manage the applications quickly. So now with this background, let's understand what is SDLC. What is SDLC? Maybe if you are from a computer background, maybe if you are computer graduate in BTech, BSc, or maybe MCA, you might already know what is SDLC. But let me start with the SDLC here. So SDLC stands for software development life cycle. Software development life cycle. So here, this SDLC is a one structured process. This SDLC is one structured process followed by the software companies, to build and test and deploy and maintain the application systematically. This SDLC stands for Software Development Lifecycle. Basically, it's a structured process. It's a structured process followed by any software companies, like you take IBM, you take TCS, Infosys. So any software companies who is working on any applications or a software, they will follow a structured process in order to build, in order to test, in order to deploy, in order to maintain the softwares systematically. So here you can think SDLC as like a roadmap. You can think of SDLC. You can think of SDLC as a roadmap. SDLC as a roadmap to roadmap that will ensure. Basically, you can think of SDLC as a roadmap that will ensure software, application software or a software is developed with proper planning, developed with proper planning, with the quality also very important in application or a software, and with the minimal risk. So you can think of SDLC as a roadmap that will ensure any application or any software is developed with proper planning, with quality and minimal risk. Basically, it's a structured process. It's a structured process followed by the software companies to build, test, deploy and maintain the softwares systematically. So here, why do we need first SDLC? Why people has to follow SDLC? Why? So this SDLC is very important, because here you need to properly plan, design, develop, test and release. Suppose let's take one real example. Suppose this SDLC is like a roadmap that you need to follow to develop the application with the quality and the release here. Suppose you take one real example. Suppose you wanted to construct one house. Suppose imagine you wanted to construct one house. So without proper requirements, without proper design, without proper planning, without proper budget and estimate, will you start directly the house construction or a home construction? Suppose you wanted to construct one home. Will you directly start constructing the home without proper requirements, without proper design, without proper planning, estimates? No, right? Similarly, suppose if you do that way, without proper requirements, without proper design, without proper budget and estimates, if you start the work like construction, I am just giving example, it may result delay in the constructions to be completed, and again poor quality and overcost will happen. Similarly, software development is also very similar. Suppose some company wanted to develop one application or a software without the proper process, without the proper process, if they start working on that project, they may face deadlines, they may miss the deadlines, they may develop the software with a very bad quality, and maybe the customers are not satisfied with whatever software you have developed. So if you wanted to avoid these type of things, right, you need to follow some structured approach. That SDLC provides a structured approach. That SDLC provides a structured approach to avoid these problems. You might be thinking, sir, why we need to learn about all these things? SDLC, waterfall model, agile model. Because we are not a developers, right? Because we are not writing the code. But that doesn't matter, guys. Whether you are a developer, whether you are a tester, whether you are into networking team, whether you are into database team, whether you are into infrastructure team or a DevOps team, this is a foundation. This is foundations or basics that every software engineer to be known. So without this basics, without this knowledge, if you directly get into development or a testing or DevOps, right, you may not able to understand everything properly. So that's why first we are trying to focus on what is SDLC, what is waterfall model, what is agile model, and how this is related to DevOps. How this waterfall model or agile model related to DevOps, we'll try to understand now. So here, as I already said, this SDLC provides a structured approach. Structured approach. It provides a structured approach for developing any application or a software systematically. So in this SDLC, we have various phases. It's a structured approach, and here we have a different phases in the SDLC. SDLC phases. Anyone? What are the various phases of SDLC? Most of you guys already know in the chat box. Various phases that is involved in this SDLC software development life cycle. So here we have requirement gathering. Requirement gathering. In the SDLC phases, we have first is a requirement gathering. Requirement gathering. First phase is this requirement gathering. Requirement gathering. Next, analysis. Analysis. Requirement analysis. Analysis. Later, design. Later, design. Design. And after that, development, or we call it as an implementation. Development, or we call it as an implementation. Development or implementation. Development or implementation. After this, we have something called testing. Something called testing. Something called testing. Testing. And again, after that, deployment. After that, deployment. And again, maintenance. After that, maintenance. Maintenance. These are the various phases in the SDLC. In the SDLC. So here, what is going to happen in the requirement gathering? The first phase. So the first phase in the requirement gathering, what happens, right? The customer will explain what they want. What they want. In the requirement gathering, they will explain the requirements of that application or requirements of the software. Let's imagine you wanted to develop one online shopping website. Imagine, maybe you take business, you take some business. There are a lot of business people available, right? So maybe you are running one shop, maybe you are running one shop, maybe you are running one furniture shop, or maybe you are running some electricals, I mean say electronics gadgets, like you are having very big shop and you have so many branches, offline branches, but you wanted to develop one online website for that business. Let's imagine let's imagine you take one example. You wanted to develop one online website. Maybe you may reach out to some software company, you may reach out to some service based company, and you need to explain what you need, requirements. Suppose example, I am taking one example. Suppose some company wanted to develop one online shopping website. Example I am taking, maybe you take maybe online shopping website, like maybe take maybe Flipkart or some similar to that. Suppose some online shopping website I'm just giving. Otherwise maybe online banking website, maybe online banking website, or online insurance website, or online food delivery website, or online cab booking website, whatever. That can be e-commerce domain, that can be hospitality domain, that can be healthcare, finance domain, that doesn't matter. I'm just taking one example. You wanted to some company wanted to develop some application. Maybe let's take LIC. I'm just taking example LIC as a business, LIC as a company. So LIC as a organization, they wanted to develop one website. They wanted to develop one website, or they wanted to develop one application, online application, or we call it as whatever website, right? Suppose online application or online website, insurance based, let's imagine. So LIC as a company, they wanted to serve their customers online also. So here, that as a as an organization from LIC, the directors or senior directors from LIC organization, they will sit with business analyst, BA, business analyst, BA. So they will that business analyst will collect the requirements. Business analyst will collect the requirements. Suppose just to give an example, that can be anything. Maybe online LIC insurance based application, LIC application, the website. So here, first we need to collect the requirements. We need to collect the requirements. So requirements here, registration, user registration, that policy holders can register into their this portal, login. Again, search policy. LIC as a company, they may offer so many policies, right? That search policies features should be there in that application. Again, select a policy, search policy, right? Purchase policy. These are like a features or a modules. Purchase policy. Maybe they already have a policy, they should have an option to renew the policy. These are like a requirements of that application. Users should be able to log into the portal, and they should be able to search the policies, and if they wanted to purchase any policy, they can purchase the policy. If they already have the policies, they should be able to list their policy, or maybe my policies, a renew policy, claim policy, surrender policy. Like these are like a business requirements. Surrender policy, right? And again, update nominee. These are like a functionalities are requirements. So that in the first phase of the software development life cycle, first we need to collect the requirements. Here again, suppose here again, there are two types of software companies: product based companies, service based companies. Imagine LIC as a company. They don't have their own software team. LIC as an organization, Life Insurance Corporation of India, as an organization, let's imagine they don't have their own software team, software unit, right? Maybe they cannot develop the applications or softwares for themselves. In that case, maybe LIC as an organization or LIC as a company, if they don't have their own software unit, software team or application team for developing, deploying, maintaining the applications for themselves, then they can reach out to some service-based companies. Service-based companies. There are so many service-based companies again available. There are so many service-based companies available. But service-based companies like TCS, Infosys, Wipro, Accenture, Capgemini, most of the majority of the software companies are service-based companies. They are giving the software services. They are giving the software services to some other organizations or some other companies. Suppose LIC as a company, LIC as a company, they don't have their own application team, software team. They want some applications to be developed and maintained for their customers, but they don't have their own team. Maybe they can reach out to some service based companies like Infosys, Wipro, or HCL, like that. Again, there will be a business analyst. Imagine LIC as a company, LIC as a company, they approached or they reached out to, consider they reached out to maybe TCS. So they reached out to TCS and they will, the TCS is going to provide the software services. The TCS is going to provide the software services to the LIC. Now, in the business terminology, so here LIC becomes a client. LIC is a client to TCS. LIC is the client to TCS because the LIC has given the project to the TCS. When it is coming to the LIC is the client to the TCS. Again, here TCS is a vendor. TCS is a vendor. It will become a vendor to LIC. So this terminology is also very, very important. Suppose you are working in TCS. You are working in TCS on LIC application or LIC project. Then who is your client? Even though you are working as a permanent employee in TCS or maybe contract employee in TCS, that doesn't matter again. So who is your client again? Suppose you are a developer, you are a DevOps guy, you are a tester, you are a DBA. If you are working on LIC application or project, the client is LIC. Right? So this terminology is also you need to understand in the business terminology. So here there will be a business analyst in this requirements gathering phase. In the requirements gathering phase, there will be a business analyst. The BA, the business analyst will work with the stakeholders. The stakeholders means the top leadership. The top leadership from LIC, they will work with them and they will come up with requirements. So the output of this requirement gathering is requirement specification, SRS we call it. So here first phase is requirement gathering. So here who is going to involve? The business analyst. The business analyst is going to involve here and they will work with that stakeholders and they will collect all the requirements first. So the output is requirement documents, requirement specification here. So this is first phase. So after this, the second phase here, analysis, requirement analysis will happen. So again, here they will analyze these requirements, whether whatever requirements has been given by that client, is that technically feasible. Again, whatever requirements they have given, is this requirements can be technically feasible to implement or not? And again, here requirement analysis will happen. In this analysis, a technical team will involve here. Technical team will involve like a technical architect, application architects, right, and infrastructure architects. They will involve here. They will analyze the requirements, and they will try to do the technical feasibility. Is this requirements whatever has been given, is this technically possible to implement? And again they will decide which technologies or which programmatic languages can be used to develop that requirements. And again, and in how much time estimation, how much time it is going to take in order to develop and test and release this requirements, and how much team size is required, like how many developers required, how many testers required, right? How many DevOps engineers required, and how much time it is required. So here in this analysis phase, the project managers and the technical managers will involve. They will prepare the timeline, they will prepare the team allocation, they will prepare the budget, and they will decide the technical stack. They are going to decide the technology, and they will come up with the team size and the budget, timeline, like that. This is analysis. After this analysis, next phase is a design. So here the technical architects is going to design the system, design the application. So in this design, like UI or ux design will be there, like how that front end or UI should look like, how the login page should look like, and how the registration page should look like. That UI design or UX design will be done. And again, API design, the back end design, designing only, not development. And here database design, like tables, entities, columns, database design will happen here. Various people will involve here in the designing phase, right? And basically in this designing architecture, application architecture will be designed, the UI design, backend design, right? Database design, like that. Here the architects will involve here. And after designing, the next phase is the development. The next phase is only development or implementation. So here, who is going to involve here? Again, who is going to involve here? The developers is going to involve here. The development team or developers is going to involve here. So here the development team will start developing the applications as per the requirements, and as per the design given by technical managers and the team leads. The team leads will prepare high level design documents. This technical team will prepare high level design documents, right? And as per the design and as per the requirements, the developer will start developing here. The front end team, let's imagine the front end team or UI team. The front end team will develop front end or UI developers. Front end developers or UI developers will develop the UI code, user interface code. And again, backend team or API developers. So backend team or API teams develop APIs, backend code. Backend developers will develop the APIs, application programming interfaces. And again, maybe database team will start designing the database tables, columns, like that. Here development team will involve. The development team will start developing the applications, that application code. Again, after development, again, first this application will be deployed into lower environments like dev environment, QA environment. So here the testing team, after this development is done, the testing team has to test that. In the testing phase, who is going to involve? QA team, quality assurance team. They will do the functional testing, regression testing, performance testing, security testing, and they are going to report any bugs. If there are any bugs in the functionalities or security or performance, they will report that bugs to the development team. again the development team will start working on that bugs and again redeploy that into lower environments. After thorough testing and after thorough approval, next is deployment. So this deployment is like a deploying or releasing this application to the production environment. So here, after deploying to the production, again still we have something to be managed, maintenance. Even after releasing, maybe in the production also some functionalities may not work, maybe it may break. Again, we may need to, after release also, we may need to do the bug fixes. After release, again, we may need to enhance some new features like that, future enhancements like that. So basically, these are the various phases in the SDLC. This is SDLC model, SDLC. So here, again, in order to implement this SDLC, again we have something called waterfall model. Nowadays, there is something called agile model. But before I go to waterfall model, before I go to agile model, I hope is everyone clear what do you mean by SDLC and what are the various phases involved in SDLC and who is going to involve in which phase and what is the outcome of that phase. Is everyone clear? Okay. Now let's understand waterfall model. So this waterfall model is a linear and sequential SDLC model. This waterfall model is a linear, it's a linear and sequential, sequential SDLC model, software development lifecycle model, where each phase must be completed. Each phase must be completed before the next phase, begins. So this is like a linear and sequential model. Waterfall model is like a linear and sequential model. Like first, this requirement gathering should be completed. After that, requirement analysis. After that, only we can start design. After designing is completed, then only we can start the implementation. After implementing, only testing. After thorough testing, releasing to the production. Finally, maintenance, like that. Sequential or a linear approach here. So in this SDLC waterfall model, unless until this phase is completed, we cannot start with this phase. Unless until this phase is completed, we cannot start with this phase. Unless until this phase is completed, we cannot start with this testing phase in the lower environments. Unless until thorough testing is completed, we can't deliver to the production. So this is a linear and sequential approach here. But here, as I already said, in this waterfall model, each phase must be completed before the next phase should begin. So here, each phase starts only after completing the previous phase, right? So here we have lot of challenges. Or problems with this one. So here, suppose here the resource utilization is very poor. Suppose unless until this requirement analysis and requirement gathering is completed, is this development team can start developing the application code? Is this development team and that development team like UI team, backend team, can they start working on some code unless until all the requirements of that application is collected, all the requirements of that applications are analyzed and designed? Is that development team can start developing the code here? No, they are ideal. And again, unless until Unless until this design is done, they cannot do the development. Maybe we have a testing team. Maybe imagine this development team. This development team is taking 6 months. This development team is taking 6 months to develop all these modules or all these features. Is this testing can be started in the initial stages of the development? Suppose this development team is taking 6 months to develop all the functionalities, all the modules. So is this testing team can start testing the functionalities very early stages of the SDLC? No. Again, this testing phase again has to wait for the development phase to be completed. Again, this testing team is taking maybe 2 months or 1 month to do the thorough testing. Again, we can't do these deployments to the production unless until this testing is done. So here we have a lot of challenges. Advantages also there. It is this waterfall model is easy to manage and simple to understand, but a lot of challenges or drawbacks also there in this waterfall model. So here, long release cycles. Suppose can we release that applications or softwares like very quickly, like within like monthly or every 10 days or every 15 days? Is it possible to release the applications or functionalities if anyone is following this waterfall model, like every 10 days or every 15 days or every 1 month? Is it possible to release here? No. So long release life cycle, long releases. Maybe long release means 6 months once, 12 months once, like that the release will happen. But again, suppose imagine you collected the requirements, and you finalize the requirements, you have started the design and implementation. But later you are in this phase, later that stakeholders came, they are trying to accommodate some new changes. They are again changing the requirements. Already you have completed this requirement, already you started design, you are into implementation phase, but later they came and saying some changes in the requirements. Do you think is it easy to accommodate that changes in this waterfall model? Easy? Do you think is it easy? No. Again, it is very difficult to accommodate that changes. And again, here customer feedback also very late. Customer feedback means maybe the LIC as a company has to wait maybe 6 months or 8 months to see the output of our work, the outcome of our work. Suppose maybe the development team taken 6 months, the testing team took 1 month. Finally, after 7-8 months, you have deployed and you have given to the customers. But maybe after 7 months, they may see that this functionalities could have done in a better way, and maybe this page should have looked like something else, like that. So here feedback is very late here. So here customers feedbacks come very late, and again we can't immediately implement that feedback. So here there are a lot of challenges or drawbacks with the waterfall model. With this waterfall model. But this type of waterfall model can be followed in government projects, right? Defense systems. Here there is no business involved here. Government projects, right? Government applications. No one worries about even the application is down, even the application is having very simple features, simple functionalities also. But this waterfall model is not a better approach for applications or projects where like enterprise applications, business applications. So this is where there is something called agile came into the picture. Agile methodology. So before I jump into agile methodology, right, is everyone clear? Waterfall model, I mean to say, till 2010, till 2011, 12, every application or every project used to follow this waterfall model only. So that time the resource usage is very poor. I mean to say, developers are ideal when the design is happening, and again testers are ideal. They don't have any work when the developers are doing development, right? So that time resource usage is very poor, and software people are like luxury people that time, right? Because when the design is happening, developers don't have any work. When the developers is developing, testers don't have any work, like ideal. So early 2012, again early 2012 13, again started companies started following agile methodology or agile process. So before I jump into agile, I hope everyone clear what is a waterfall model, what are the problems with waterfall model, if any application or any project following this waterfall model. Okay, now let's understand agile methodology. So here, agile methodology, this is not a linear, this is not like a linear or sequential approach. It is not a linear or sequential approach. This agile methodology is like a iterative model. This agile model, again it is a SDLC lifecycle, SDLC model only. Agile is an iterative agile is an iterative software development methodology, or that SDLC, software development methodology. Iterative, not sequential. Iterative or incremental way. Incrementally we are going to release, instead of releasing everything at once. Instead of releasing everything means all these requirements, instead of releasing everything once, instead of uh, instead of developing everything once, instead of deploying everything once, instead of testing everything once, like iterative model instead of sequential. So agile is an iterative software development methodology where where the where work is divided work is divided into small cycles, called, we call it as a sprints. Typically typically in agile methodology, most of the people, you already following agile methodology in your applications or projects, whether you are a developer or whether you are a tester. Typically, how many weeks each sprint is planned? Most of the companies follows 2 week sprints. Most of the companies follows 2 week sprints, but some companies may follow 3 week sprints. 3 weeks. So I mean, say 10 to 15 working days. 10 to 15 working days here. 10 to 15 working days here. So here, instead of everything developed together, and instead of everything deployed and tested and released together, here we are going to release incrementally, iteratively, step by step, right? So here, each sprint is going to deliver, each sprint we are going to deliver some working and testable piece of software. So here, in each sprint at least each sprint we should deliver each sprint we should deliver a working and testable, that that application should work, that functionality should work, and we should, that the tester should be able to test that testable piece of software. So here, in each sprint we need to deliver something. So here, just to give an example, like first, instead of developing user registration, login, search policies, purchase, let's imagine I'm taking one application. Instead of developing all these functionalities together, we are going to do, in first sprint maybe we can start developing user registration. Maybe in the second sprint we can develop the login. Maybe once we develop the first, in the first sprint, the development team developed this maybe the operations team released this, the testers can start testing the at least the registration functionalities immediately after first sprint, where in the second sprint the development team is working on login. During that time itself is the testers can start testing this user registration functionalities, and they can give the feedback or bugs immediately. Yes. So here, like a step by step here. In each sprint, we should deliver something. In each sprint, we should deliver a working and testable piece of software. Example, sprint 0. There is something called sprint 0. In sprint 0, we have something called planning. In sprint 0, most of the time planning will happen. So what functionalities we can develop in the first sprint? And again, we need to take some functionalities that is not depends on other functionalities like that. In the sprint 0, again planning will happen, sprint planning, which modules or which functionalities we can develop, and we can who can work on which task, like that. So here maybe in the sprint 0 planning will happen. Then sprint 1, maybe registration is targeted. Sprint 1 again, in sprint 1 what functionalities can be developed and delivered, again we can plan according to the team size, so you have a proper planning. Let's imagine you have a 10 developers, and out of 10 developers, let's imagine the 2 developers on vacation. You are going to commit how much you can deliver according to the team size, according to the timeline. You can commit what functionalities you can deliver. I'm just giving example. In sprint 1 registration we are going to develop and deliver. In sprint 2, let's say login functionalities can be developed. In sprint 3, maybe search policies, like that. I'm just giving example, right? In sprint 4, something like this. Finally, after some sprints, finally everything is deployed, everything is delivered, maybe whatever you wanted to, whatever functionalities like this you can plan like sprint wise. So here again, in agile we have a different roles. There is something called scrum master. There is one person called scrum master. There is one person called product owner. So there is something called product owner. So the product owner is also one type of role. The product owner responsibility is going to talk to the customer. Customer means maybe for whom you are developing that software. That product owner is going to work with that LIC company, and he will talk to the customers, and he will prioritize the features. What features has to be developed in which sprint, he will prioritize the features. That product owner is going to represent the customer, and he is going to prioritize the features. And again, there is someone called scrum master. So scrum master is again one role. That scrum master is going to run the scrum. He is going to run the show. That development delivering. This is scrum master is going to facilitate. This agile process. He will work with the development team. Testing team, infrastructure team, everyone. He is going to remove any blockers. If there are any blockers for developing this feature, first he will try to remove that blockers, and he will ensure that the scrum practices are going smoothly. The scrum master is going to assign the task. And he is going to have a discussion. He is going to have a scrum call. He is going to have a scrum meeting. We call it as a daily stand-up meeting, right? So daily stand-up meeting will be run by that scrum master. He will ask which task you are working today, what you have done yesterday, is there any blocker for your task to complete today. So he is going to facilitate that agile process, and he is going to assign the task. He is going to track the task. He is going to remove the blockers, and he will facilitate the development and that sprint going smoothly. So there is a development team again. The development team will design, develop, tester delivers the product. So here in Agile, we have something called sprint planning, daily stand-up call, sprint review, and again there is something called retrospective meeting. After completing this first sprint, again there will be a meeting. We call it as a sprint retrospective meeting. So here in that meeting they will discuss what went good in this sprint. Is there any backlog means you have committed to develop something but you have not completed. Maybe that will be backlog for the next sprint. Is there any backlogs that has to be taken care in the next sprint? What went well, what didn't went well, what we can do better in the next sprint? These type of things will happen in the retrospective meeting. And in the daily stand-up call, what you have done today, I mean say what you have done yesterday, what you are going to do today, is there any blockers or issues when you are going to complete? That is what we are going to discuss on the stand-up call. So here advantages of agile methodology. So here it is like a iterative. So you are going to take one functionality, you will plan that, design that, develop that, test that, deploy, and again you get the feedback, and again you plan one more functionality in the next sprint, design, develop, test, deploy, get the feedback. It is like a circle, not a linear. So in sprint one, you plan something, you design that, you build that, test that, deploy. In the second sprint again, plan something, design something, build a test, get the feedback. Again, plan something, design something, like that. So here we have so many advantages with this agile methodology. What is the primary advantages of agile methodology here? What is the primary advantages of agile methodology here? Anyone? Primary advantages of agile methodology here: faster delivery. We can quickly deliver, faster delivery of features or requirements. Again, continuous feedback. Continuously we are going to get the feedback, customer feedback. Suppose in the first sprint you have planned 10 working days. In the first sprint you have launched a registration functionality. Within 15 days itself you have delivered something that is testable. Is the customers, I mean say, is the customers of that software, can they test that and they can give the feedback whether we have done very well, whether is there any improvement that has to be taken care? Can we get the quick feedback very quickly instead of waiting for 6 months, 8 months, like that? Can we get the faster feedback? Yes, we can get the faster feedback. And again, can we adapt the changes in the requirements also, because we are immediately getting the feedback? Can we adapt the changes also if the changes are suggested by the customers of that software? Can we adapt the changes also immediately? Yes. So here continuous customer feedback, and again easier to adapt the changes, in requirements, and most importantly, satisfaction. Customer satisfaction is very, very important. Customer satisfaction, higher customer satisfaction. So you are delivering something in 10 days, you are delivering something in 20 days. So the customer also very happy, because he can see working model, working prototype. So highest customer feedback or customer satisfaction. But here imagine if people are started developing the projects using agile model. Again, if we are manually taking the code, manually building the code, manually deploying the code, manually testing the code, again, do you think we can achieve this rapid speed in a manual process? Suppose some project started following agile model. Every day developer will make changes so many times. Every day continuously developer is making the changes to the code, and every time there is a change in the code, you need to get the code, compile the code, check the code quality, code coverage. You need to build the code, deploy the code, and again test the code. If you are manually doing these integrations, deployments, again, can we achieve this speed, the expectation of agile? Again, in the continuous integration, continuous deployments, continuous testing, if you are manually doing, it is very difficult again. So this is where DevOps came into the picture. This is where DevOps came into the picture for bringing everyone on the same page, everyone on the same page, and so many tools, so many automations here, right? So this is where DevOps came into the picture. But when people following waterfall model, we are not building the code, we are not releasing the code very frequently. But there you have a luxury, you have a time, you can manually take the code, manually configure the servers, manually deploy the code, manual testing, everything fine. But here when we start following in agile model, within one sprint, within 10 working days, you may need to build a deploy test so many times. Again, if you are manually doing this continuous integrations, continuous deployments, testing, it is very difficult to achieve the timelines, right? And again, if you are manually doing, there are a lot of chances for bad code, so many bugs again, like that. So this is where the DevOps came into the picture. This is where DevOps came into the picture. Instead of manually taking these changes and manually building, manually deploying, manually testing, we can implement a DevOps methodology or a DevOps practices in the application, so that we can automate, we can collaborate, we can automate, we can quickly deliver, and with good quality, less bugs also. So here, so this DevOps is extending, the agile by automating. DevOps is extending the agile methodology by automating building, testing, deployment, and operations. So it will enable the organizations to release high quality softwares continuously. This is why modern companies, like any company you take, like Amazon, Netflix, Google, or any applications you take, they are relying on the DevOps practices. They are relying on the DevOps practices to accelerate the application build and deployment and testing here. I hope now you got a complete clarity why this DevOps came into the picture, what is the history behind this DevOps, how this DevOps actually came into the market. Is everyone clear? Whatever has been explained so far. So here, where exactly DevOps fit into this SDLC? Where exactly this DevOps fit into SDLC? DevOps is not a separate phase in the SDLC. There is no phase in the SDLC like DevOps. So here, in every phase of the SDLC, there is a DevOps tools, DevOps technologies, DevOps methodology. So DevOps is not a separate phase. DevOps is not a separate phase of the SDLC. Instead, it will enhance multiple phases by introducing collaboration and automation. So here deployment automation can be implemented using CI/CD pipelines. Deployment automation can be done by using CI/CD pipelines, using tools like Jenkins, GitHub Actions. And again, you can do the testing also, automated testing in the source code using security tools, DevSecOps like SonarQube, Trivi. There are so many tools for scanning the source code and identifying the security risks or vulnerabilities. And again, automation testing. And again, maintenance, continuous monitoring, continuous logging, also using monitoring tools. So the DevOps is not a separate phase in the SDLC. DevOps is not a separate phase in the SDLC. Instead, in every phase of the SDLC, we have some DevOps tools. We are introducing DevOps tools to collaborate and automate here. So I will explain the DevOps workflow. I will explain the DevOps workflow with one diagram. but whatever has been explained so far, is everyone clear? Okay. Now let's get into some kind of a diagram. Here, let's understand we have so many developers. Let's understand these guys are developers. These guys are developers developing the application code. And these so many developers are going to develop the code. And all these developers has to collaborate their source code. All these developers will write the code and they wanted to share the code. Collaboration also important. Imagine these are so many developers are developing that application code, and here these guys has to develop the code, they have to collaborate and share the source code. So this guy is writing something, maybe this guy is writing maybe login functionality UI code. And again, let's imagine this guy is developing login API, and maybe this guy is again developing maybe login database logic, this some database functionality, this code internally talk to database like that. But this guy has to share the source code with this guy has to share the source code with this guy like that. Collaboration also required here. And before these guys develop, again planning. For planning we have a tools again. You might heard something called Jira. So Jira is a project management tool. In the Jira you can create your sprint planning, like who is going to assign, who is working on which task, what is the status of the task, whether it is started, in progress, completed, like that. But anyhow, here I am directly starting with the development. So these guys are developing the code and these guys has to collaborate the code. Here again, is this guys can share the source code via email? Is this guys can share the source code via communicators? Is that recommended again? No. So here we need some kind of a centralized system where we can maintain the source code. So here the developers are these developers, whatever code they are going to write, that code, it should not be shared via emails, it should not be shared via communicators. Here again we are going to use some tools. We are going to use some tools called SCM tools. In this we are going to use something called SCM tools. SCM stands for source code management. SCM stands for source code management. Under this SCM we have so many. Either you can use GitHub, otherwise you can use Bitbucket, otherwise you can use GitLab, azure repos or maybe AWS code commit, etc. So there is something called SCM tools. The most popular and widely used SCM tool is GitHub. We will discuss about this GitHub in our DevOps training in a detailed way. Here we will try to understand Git commands, Git branching strategies, branches, tags, releases, Git commands also. Don't worry, but understand here there is something called SCM repository. So here we are going to use something called SCM tool, SCM software. So here we are going to create a repository. Repository is like one folder. You can think of repository is like one folder in this SCM, right? So here these developers will try to write the code locally. They can commit and push the code here. They can write the code, they can commit the code, and they can push that code, whatever they are developing here. So again, these guys are committing the code here, like a central source code management, centralized repository, source code management repositories. So here maybe this guy developed something, he has committed. This guy developed something, he has committed. Again this code this guy can take, and again if required he can modify, and again he can commit, like that. So here we have something called SCM, source code management tools. So here as a developers, they will develop the code. They will develop the code. And as a developers, they will write the code. They will commit the code to this SCM repository. But as a DevOps engineer, what is our responsibility here? What is our responsibility? What do you think? What we need to do here? Roles and responsibilities. Roles and responsibilities of the DevOps engineer here. In this SCM, what we need to do? Maybe you might be already working as a DevOps engineer, or maybe already. So here, you need to create a required repositories. You need to create a required SCM repositories here, and you need to give the required permissions to these developers. You are responsible for creating a required SCM repositories, and you need to define the branching strategies, and you need to do the administration, GitHub administration. You need to give the required permissions to this application team. But in a regular session, we will try to understand again how to do this. What is GitHub? How to create a repositories? What is branches, right? And what is commits? Like, and also we'll try to understand the branches, tags, releases, committing, pushing, pulling, all those things. But as a DevOps engineer, we are responsible for creating a required repositories for that application team, and we are responsible for giving the required permission. Now, let's imagine they are developing the code, they are committing the code. Now, once this code is available here, then what we need to do? We need to take the code. Maybe we need to build that code. We need to build the code. So here we need to build. We are going to take the latest code. Here we call it as a build process. Build. We need to build that code. So here, imagine you are a build and release engineer. Manually also you can do, otherwise you can do automation. But let's understand first manual process. Later I will tell the tools that can be used for automation. So here, whenever there is a change in the code, right? Whenever maybe someone modify the code and push the code here, immediately you need to take the latest code, get the latest code, pull the latest code here. And again, based on the programmatic language here, again, we may need to use some build tools to compile the code, execute unit test cases. Again, the unit test cases is different from integration test cases. The unit test cases also will be developed by the development team, right? So we may need to execute the unit test cases. We need to compile the code, execute unit test cases, create application package like that. Here again, we are going to use some build tools. Again, here we are going to use some build tools to build that code. Whatever code you have taken here, we are going to use some build tools. So here, different programmatic languages has a different tools, build tools. We'll discuss again in the regular training. Don't worry about that. This is just a demo where you can understand workflow, right? So here we can use some build tools. Like different programmatic language has a different build tools. Like Java has a build tool called Maven or Gradle, or maybe if it is application developed in Node.js, we have something called npm. Like that, we have a build tools. So here, using this build tools, we are going to build. Build means compiling, right? So here we are going to compile the code. And run unit test cases like that. Unit test cases here. Then after that, right, you are going to create a package, like a application package. We will discuss, don't worry. So in case if it is a Java, we are going to create a package, application package. Like we have something like a jar file, var file, like that. We are going to build the package. And again, developers are developing the code. Again, we need to check the code quality also. Whatever source code that is developed by that development team, is that source code is having the standards. Maybe freshers also will be there, senior people also will be there. And here whatever source code developed by the development team, whether the source code has any security risk, security vulnerabilities, is that source code is having a quality or any vulnerabilities, we need to check. Again, if there are thousands of source files, if there are thousands of source file lines, is that a team lead or manager, is it easy to manually review the code again, whatever source code developed by the development team? Is that development team lead or manager, is it easy to check the source code line by line, whether the source code has been developed with the standards? And is there any bad code, is there any security risk vulnerabilities? So do you think is it easy to manually review? No. So here again we have something security, we need to check the code quality, code coverage also. Again here we have some tools, again here we have some tools in the DevOps, right? So here the SAST tools, we call it as a SAST tool. SAST tools, SAST. SAST stands for Static Application Security Testing. You might heard something called Sonar Cube, you might heard something called checkmarks, checkmarks, checkmarks. We have something called Vera code, but all are under same category only. All are under same category. Again, we are going to check the code quality and code coverage also. Again, we are going to check the code quality or a code coverage using these type of tools: Sonar Cube, Vera code, Trivi. Again, instead of manually reviewing the source code, you can give that source code to these softwares. Sonar Cube. Yes, please be unmute. I have disabled the mic. Okay. Sorry, guys. So here you can give the source code to this type of SAST tool. The source code it will scan, security scan, DevSecOps security. It will scan the source code and it will give the report, a detailed report. Is there any security risk, security vulnerabilities, right? Is there any code duplication, right? And how much test cases has been passed, how much test cases failed, unit test cases, how much code coverage is there. So this type of report will be given. So instead of manually checking the code quality, code coverage, static application security, we can use tools like this. So you can save the time and you can improve the quality of the source code also by scanning this source code like that. Again, you can create a package. You can create a package if the source code quality is good, unit test cases is executed properly. You can create a package. Once you create this package, you need to deploy that package in some servers. Again, you need to deploy this package in some servers like dev servers, dev environment. So maybe here again you will create a servers. Here you will create a servers. Again, we will discuss about servers, storages, networks, load balancers, databases, on-premise infrastructure, cloud infrastructure like AWS. In AWS, how to create a servers, how to create a networks, how to create a load balancers, and how to use the storage in a detailed way. In our regular sessions, we'll discuss all these things. We'll discuss about the Sonar Cube. We will discuss about the Maven, NPM. We will discuss about the GitHub. Don't worry. So here we are going to create some servers. We are going to have some servers with some operating system. With some OS, we are going to install with some OS, and you are going to deploy your applications here with required softwares and configuration. So again, we will discuss about virtualized deployments, containerized deployments, what is containers, like how to build and release applications as a containers using Docker, and what is container orchestration, what is Kubernetes also we'll discuss. But for now, understand this is a virtualized deployment. Here you will install required softwares like Java, Python, middleware softwares, and you will do the required configurations, and you will set up the required environment, and finally you will deploy this application package. But again, you wanted to share this package with multiple people, multiple teams, right? Maybe you can use some other tool, other software. Again, you can use something called Artifactory, something called Artifactory tools. The way we have a SCM repository, we have something called Artifactory repositories. Artifactory, Artifactory, Artifactory repositories. Artifactory repositories. Using Nexus or JFrog, you can create a repository where you can store these type of application packages, so that in the future, in whatever system you need this package, you can download this package from this repository. Maybe in dev server you have deployed, later you wanted to deploy in production, or maybe some other team need this package, you can download this package from this Artifactory also. So here you can upload this package also to the Artifactory, and you can download that package in any system and deploy like this. Suppose in real time, again, instead of one server, we are going to deploy our application in multiple servers. Single server is like a single point of failure. Suppose if something goes wrong with this system, or maybe so many requests come to this application, again this system and this application may not work. So here we are going to deploy this application in multiple system, and we are going to bring a load balancer. We are going to bring a load balancer. We will discuss about all these things, how to set up a load balancer. We will discuss about software load balancers, hardware load balancers, cloud managed load balancers, like Nginx. Using Nginx, you can set up a load balancer. You can distribute the load or a traffic. We will discuss all these things, the DNS concept, load balancer concept, all those things. So here we are going to deploy that application here. Consider this is a dev environment, and the development team will do the high level testing. If everything looks good, then we will deploy this code, same application, into the QA environments for testing. Again, the QA team can do the testing here, in the QA environment or a QA servers. If everything looks good, finally we are going to deploy to the production. That QA team will do the testing, and if a thorough testing, finally we are going to deploy to the production. Here we are going to deploy to the production. Again, we can deploy that applications as a virtualized deployment, or maybe containers. We'll discuss about what is Docker, what is Kubernetes, right? How to build and release applications as a containers. What are the problems with virtualized deployments? What are the advantages with containers? We'll discuss. Don't worry on that part. But understand, the developers will develop the code. Whenever there is a change in the code, you need to take the latest code, compile the code, run the unit test cases, check the code quality, code coverage, create an application package, and upload that application package in Artifactory. And in dev servers, you deploy that package, and again deploy that package in the QA servers, and again after thorough testing, release that into the production like that. Again, here manually, imagine every time developers are making the changes. Imagine daily 10 times, 15 times the developers are making the changes. Every time there is a change in the code, we need to continuously integrate that changes. You get the latest code, again compile the code, execute the unit test cases, check the code quality, code coverage. If anything is failed, again you need to tell the developers, like unit test cases failed, code quality is not good, like that. If code quality, code coverage, unit test cases also good, create a package, deploy the package into the dev servers, and again deploy that into the QA, and again manually doing a testing, integrations, deployment testing. Here manual process, again lot of challenges are there. Time taken, human errors. Manually when we are doing, you may do some mistakes, maybe intentionally or unintentionally you do some mistakes. Maybe when you are manually doing this, maybe you bypassed this scan, security scan. Maybe you have just pulled the code, compile the code, executed the unit test cases, create the package, deploy that package in dev, deploy that to QA. Testing team has tested, functionality wise it is fine. So again you release to the production. But you have skipped this. But in the later stages, once you deploy to the production, you have realized that the source code quality is very bad. Once you release to the production, do you think rewriting the source code again, is it safe? Once it is released to the production, later stages you have identified the code quality is very bad. Again, if you touch the source code, again it will break the functionalities. So here you need to, in DevOps there is something called a left shift. In DevOps there is something called a left shift. You need to follow the left shift process. You need to shift the security into every stage, early stages of your application life cycle. But when you are manually doing, there is a chance that intentionally you may bypass this. But when we are using automation, you will reduce the time. Every time there is a change in the code, automatically take the code, compile the code, run the test cases, execute the source code, quality check, create a package, deploy the package. And again if the testing team has implemented automation test cases using Selenium or any other framework, once it is deployed to the dev, again you can execute the test cases also for automatically testing the functionality. And again you can release or promote that to QA, like that. So here you can bring automation. You can implement continuous integration, continuous deployment by writing some kind of a pipelines, by writing some kind of a script. So here you are going to use a CI/CD tools. Here you are going to use a CI/CD tools to implement this continuous integrations, continuous deployments, continuous testing also. So the most popular and widely used CI/CD tool is Jenkins. The most popular, widely used CI/CD tool is Jenkins, right? You can use a Jenkins and you can write a pipeline. You can write a pipeline. We will discuss what is pipeline, what is scripted pipeline, what is declarative pipeline, and again what is shared libraries also. Don't worry. And whenever there is a change in the code, instead of manually performing all these things, all these stages or steps, you can write a pipeline, Jenkins pipeline or GitHub Actions pipeline, where it will take the code, compile the code, execute the source code, quality check, create a package, upload the package, deploy the package. Again you can write one more pipeline, you can execute one more pipeline. That pipeline can execute the test cases. It can execute the end-to-end test cases against a dev or QA, and it will give the report, like that. So you can implement the pipeline, CI/CD pipeline, using Jenkins. And also you can bring a notifications. You can send a notifications also. Using that pipeline, right? Suppose whenever there is a issue in the compilation, immediately that Jenkins can send the notification to the development team. Maybe if there is a issue in the code quality, it can send the notification. It will not proceed further. To the next stage. Suppose code quality, code coverage is also good, it created a package, deploy that package, so it will give the notification application is deployed in dev, like that. So here you can implement continuous integration, continuous deployments, and notifications to the application team via CI/CD pipelines. Instead of manually performing all these integrations, testing, deployments, you can use CI/CD tools like Jenkins, GitHub Actions, like that. And again here maybe before you deploy the applications here, you may need to configure the servers. Maybe again, instead of manually configuring the servers with required softwares and configuration, again it's a time consuming, error prone, right? Here if you have hundreds of servers, where you need to manually install the required softwares, configurations, before you deploy this application. Again you can use some kind of a configuration management tools. The most popular widely used configuration management tools are like Ansible. And again Instead of manually doing the installations and configurations in the servers for deploying, you can use configuration management tools like Ansible. You can write a playbooks and you can execute that playbooks against the servers, so that software installations and configurations also can be automated using configuration management tools. And again, deployments can be automated using CI/CD tools. Suppose you are using cloud like AWS, Azure, GCP, just giving example, you no need to manually create the servers again. Instead of manually creating the required servers for deploying your applications, instead of manually creating a required networks, load balancers, servers, again, you can use IAC tools, infrastructure as a code tools like Terraform. So as part of this training, I have included Terraform also into this course. We will discuss about what is Terraform, what is IAC, using Terraform, how we can do the infrastructure automation, how we can provision the infrastructure, right? In Terraform, we will discuss so many concepts again, right? So here various tools will be there, various technologies will be there, and each tool and each software or each tool or each technology is trying to solve some problems, or trying to do some kind of an automation here, right? And again, instead of manually building and applying, you can use the CI/CD. Instead of manually doing a configurations, configuration management tools. Instead of manually creating the required servers, required storage, required networks, right? IAC tools. And again, once you deploy, you need to monitor. You need to monitor what is happening in these servers, whether servers are healthy, whether the servers has enough CPU, enough memory, enough storage. Instead of manually monitoring 24/7, you can use monitoring tools, continuous monitoring tools like Prometheus, Grafana, where monitoring tools will continuously monitor your servers applications, and it will set the notifications also again. So that is a continuous monitoring. And again, there is something called containerized deployments. There is something called containerized deployments. So instead of building and deploying our applications in a virtualized systems using a Docker, you can create a container image using something called container image, Docker image with all the required softwares and configurations, and you can push that image, you can deploy that as a container, and again you can use container orchestration. We'll discuss all those things, right? So here, so many tools, so many technologies are involved here in the SDLC, right? So developers will develop the code. We need some SCM tool to maintain the source code. Whenever there is a change in the code, you need to build the code, you need to compile the code, you need to check the code quality, code coverage, you need to create a package, you need to deploy that package, and again you need to test that, and you need to monitor that, right? So this continuous integrations, continuous deployments, continuous testing, continuous monitoring. So here, instead of manually doing, we can use automation with various tools, various technologies here, right? So here, this is like a DevOps workflow, right? Here, so many tools, so many technologies are involved, and each tool, each technology is used for different purpose, right? So before I explain what tools, what technologies we are going to cover in DevOps with AWS and Terraform course, is everyone clear? I mean to say the workflow, like developers develop the code, again what we need to do here, right? Instead of manually doing all these things, we can use automation tools also here, right? So now let me quickly explain what we are going to cover as part of the training. I hope everyone already has this syllabus copy. Everyone already has this syllabus copy with you, right? So first, in this DevOps with AWS and Terraform course, here, first we are going to discuss about Linux. First, we are going to discuss about Linux and Linux commands, Linux and Linux commands. So you might be thinking, why Linux? So here, everywhere there are so many systems. You have your CI/CD systems. Here you have a database systems. You have application systems like that. So in real time, when we are working for any applications or any projects, most of the time we are going to work with Linux systems, Linux servers, not Windows. Suppose you wanted to work in Linux, If you don't know what is Linux and the Linux commands, do you think is it easy to work in Linux servers or Linux environment for doing some kind of installations, deployments, troubleshooting? No. So here we are going to start with Linux and Linux commands. So this Linux and Linux commands itself may take approximately 12 sessions. 12 sessions. 12 sessions. Again, we have something called shell scripting. We have something called shell scripting. Shell scripting is again for automation, automating manual tasks. Instead of manually doing some tasks in the Linux servers, you can define a commands. You can define the commands in the shell scripting and you can execute that shell script. But this shell scripting is very easy. This shell scripting is very easy if you know the Linux and Linux commands. But here, what I have done in this batch, I have introduced Terraform. Terraform is very important now, right? Terraform is very important now. Any company, any project, if you go, people ask, do you know Terraform? Have you used Terraform, like that? So this Terraform I wanted to cover live and again in detailed way. Maybe Terraform itself may take approximately 25 sessions, 25 to 30 sessions also it may take. But in order to cover this Terraform in a detailed way, I am giving shell scripting. I am giving shell scripting also in a detailed way, but as a pre-recorded sessions. Pre-recorded sessions. Here, approximately 8 sessions will be there. 8 sessions as a pre-recorded sessions. This shell script is very easy if you know the Linux. So after completing Linux, I will go to GitHub, Git and GitHub, Git and GitHub. But here parallelly, you can spend some time on the shell scripting. But shell scripting is not mandatory when you wanted to learn Git and GitHub. Suppose when we are learning Git and GitHub, it is not mandatory that you should know shell scripting. But parallelly, when you get some time, I highly encourage you to go through this pre-recorded sessions. And if you have any doubts, any questions on the shell scripting, you can ask anytime. But I wanted to cover Terraform in a detailed way. Approximately, it may take 25 to 30 sessions live. I'm just giving this as a pre-recorded sessions. Pre-recorded sessions. Shell scripting. But shell scripting is very easy if you know Linux and Linux commands. But Linux and Linux commands are live. Linux and Linux commands also live. But shell scripting as a pre-recording sessions I will be providing. After this, right, we will start with Git GitHub. This is SCM tool. This is SCM tool. This GitHub also may take approximately 8 sessions. Approximately 8 sessions here. We will discuss about detailed way what is GitHub, what is Git branches, releases, tags, right, branching strategies, and Git commands also. We will discuss in a detailed way. We will discuss in a detailed way in Git commands also. Right. It will take approximately 8 sessions. And after this Git and GitHub, we will start with the builder tools. We'll start with the builder tools. The most popular builder tools like Maven, NPM, like that. And again Python, pip, like that. So here we'll start, maybe this Maven will take approximately 3 sessions. This is very small concept, but nowadays it is not widely asked in the interviews also, but still you need Maven. So this is SCM tools. This GitHub SCM tools. SCM tools. And after this builder tools, right, we are going to start discussing about web servers, softwares, application server softwares, web servers for hosting static web applications like Nginx, right, and application server softwares like Tomcat, application server softwares like Tomcat. So this is hardly these web servers and application servers both hardly it will take maybe maximum 2 sessions or 3 sessions. These are small concepts. These are small concepts like Nginx, and web server like Nginx, application server like Tomcat. So approximately it may take 3 sessions again. And after this, we'll try to learn SAST tool, static application security testing, security, DevSecOps. So here a security testing on the source code. SAST tool, we'll try to understand about Sonar Cube. Sonar Cube. But again, the Sonar Cube is widely used, but again, there are a lot of other alternatives in the market, but they are also doing the same purpose only. We'll discuss about Sonar Cube. And again, after this, we'll discuss about artifactory tools, artifactory tools, artifactory tools. This artifactory tools like Nexus. We'll try to understand what is Nexus. Maybe this Sonar Cube may take 2 to 3 sessions. This Nexus also may take 2 to 3 sessions here. And after this, we are going to start very important, like a heart of the DevOps, CI/CD tool, CI/CD tools. So here we are going to discuss about Jenkins. Jenkins. This Jenkins may take approximately 14 to 15 sessions, live sessions, 14 to 15 sessions. But under this category, again, I am going to cover one more tool, one more CI/CD tool. Not only just one tool, I am going to cover again another CI/CD tool also, that is GitHub Actions. That is GitHub Actions as a recording sessions. This is like a pre-recorded. So this is like a bonus. This is like a bonus. So if you have a multiple tools in the same category, maybe you have better opportunities also. But concept is same. Whether you use Jenkins, whether you use GitHub Actions, the concept is same, but the way we are going to write the pipeline, that code automation will be little different. That's it. So here we will be providing this as a pre-recording sessions again. Maybe this approximately, this also has around 8 sessions. 8 sessions approximately, right? This one on GitHub Actions, right? And after this, again, we are going to start with cloud computing, cloud computing and cloud service provider. So here we have AWS Cloud, the most popular and widely used AWS Cloud. Under this AWS again, we have so many services. We have so many services, right? We are going to cover approximately 18 services, very important services that is required to be known as a DevOps engineer, right? Like EC2, EBS, EFS, S3, right? Again, VPC, ELB, auto scaling group, and again Route 53. Again, here we have something called RDS. Again, here we have something called Lambda. Again, CloudWatch, and again ECR, EKS, IAM, like very important services. Here and there, small services also there. In a detailed syllabus, also have provided here. Detailed syllabus also I have provided here. In Maven, what we will be discussing, right? Tomcat, what we will be discussing. Sonar Cube, what we will be discussing. Nexus, what we will be discussing. And also CI/CD, Jenkins, what we will be discussing. And again, AWS, what we are going to discuss, like EC2, EBS, EFS, S3, right? VPC, ELB, Route 53, ACM, Auto Scaling Group, RDS, CloudWatch, Lambda, IAM, ECR, EKS, like that, right? And again, after that, the very important and widely used software in the market nowadays, containerization tool, containerization tool containerization tool like Docker. So this Docker is very important. Whether you are a developer, whether you are a DevOps guy, whether you are working on static websites, dynamic website, APIs, and other stuff also here. Other stuff also here, like Docker. So Docker, we will be covering in a detailed way. This AWS may go approximately 24 to 26 sessions. 24 to 26 sessions it may go. And here Docker. So what is Docker? How to write a Docker file? What is Docker image? What is Docker container? What is Docker network? What is Docker volumes? How to build and release applications as a containers? How to write a Docker files? How to what instructions can be used in a Docker file in a detailed way. So this Docker also very important. So here we are going to discuss about Docker also in a detailed way. What is Docker? Introductions to containers, containerization versus virtualization, how to install Docker, Docker architecture, Docker commands, Docker images, Docker, how we can build and deploy some sample applications also as a containers, right? Docker networking, Docker values, and how we can integrate Jenkins with the Docker CI/CD pipelines like that. So this Docker also may take approximately Docker 5, Docker approximately 14 to 16 sessions. And Ansible also I am giving, but as a pre-recording session, because now I wanted to focus more live on the Terraform. But Ansible nowadays very less people are using, because using Docker itself, people can build the packages. Using Docker itself, people can build the packages with required middleware softwares and configurations also. Nowadays Ansible is very less projects are used, but still I don't want to take any risk. So Ansible also I am providing as a pre-recorded sessions, right? Ansible also pre-recorded sessions. So approximately this Ansible also uh, around 14 sessions are there, around 14 sessions. So here the shell scripting and Ansible I am providing as a pre-recorded session to include Terraform, right? So here Ansible is a very less projects are using, because nowadays every application is built and deployed as a containers. When we are using containers, the required middleware softwares and configurations also we can create as a package using Docker. So very less projects will be using Ansible. So here we are Ansible also in a detailed way, but as a pre-recorded session. So remaining live sessions. And again here, if you are only using containerization, again there are a lot of challenges. If something goes wrong with your container, if something goes wrong with your system where your containers are running, your applications will be down, and there is no container scaling, container load balancing, all those features. So that is where we are going to have something called container orchestration tools. Container orchestration tools. The most popular and widely used container orchestration tool here is Kubernetes. So this Kubernetes will take approximately 45 sessions. Approximately 45 sessions we will be discussing on Kubernetes in a detailed way. If you complete this training, you can go with the CKAD exam also, CKA exam also. That much extent we will be covering this Kubernetes. Whether you are working on AI tools or AI softwares also, Kubernetes is required. Whether you are working on normal applications also, you need a Kubernetes, you need a Docker, you need a cloud, you need a CI/CD. So here, this DevOps is like a foundation. DevOps is like a foundation, or basically DevOps is a very important. Before you wanted to, learn something else on top of that, right? So this DevOps is very important. These tools are very important again. And again, in this Kubernetes only, we have so many things. Again, we'll try to discuss about Helm. We'll try to discuss about Istio, and again, we'll discuss about monitoring tools like Prometheus. We'll discuss about monitoring tools like Prometheus, Grafana, right? And the log aggregation and log monitoring tool like Elasticsearch, Fluentd, Kibana. This is log aggregation and log monitoring. Log aggregation and log monitoring. So instead of checking the logs in each and every system and each and every container individually, you can collect the logs and store the logs and index the logs using this Elasticsearch Logstash Kibana or Elasticsearch FileBit Kibana. This Prometheus and Grafana is a monitoring here. And again, how to build and release applications in containers using in Kubernetes using Helm charts. What is Helm charts? And how to deploy the application using Helm chart. What is Istio service mesh? How we can use Istio? Like that, there are so many things. But I have given a detailed syllabus here, right? And again, Docker Swarm is also one container orchestration software, but nowadays no one is using. But still, this Docker Swarm and the Docker Compose, this Docker Swarm and Docker Compose also I am providing as a pre-recorded session. But very less projects, very old projects are using Docker Swarm, but nowadays everyone is using Kubernetes. So this will be approximately 4 sessions again, 4 sessions. So here we are not only discussing all these tools individually. Again, we'll implement end-to-end pipelines, automation pipelines. And again, we have something called ArgoCD. We will discuss about what is ArgoCD also here. Right? So here, not only these tools learning individually. First, we'll try to learn these tools individually. After that, we'll implement a pipeline, like automation pipeline, different pipelines. Suppose developer is developing the code, committing the code, how we can use Jenkins to take the code, build the code, check the code quality, code coverage, and how you can upload that package, how you can deploy that package in some servers like Tomcat via pipeline, virtualized deployment. Once we start with the Docker, once we start with the Docker, we'll see again, once you learn Jenkins, once you learn Docker, again we will use Jenkins to, instead of manually building a Docker image, instead of manually pushing the Docker image, and again scanning security, instead of manually scanning the image for vulnerabilities using Privy, again we can automate again via pipeline. Using Jenkins, we can implement a CI/CD pipeline to take the code, compile the code, check the code quality, code coverage, build a Docker image, and scan the image, push the image, deploy that image as a container in a normal Docker. And once we learn Kubernetes concepts again, after that, how we can deploy in Kubernetes, how we can deploy that in Kubernetes. Once you learn Kubernetes, like what is pods, deployment, services, config map, secrets, in a detailed way. Again, automation, how we can, the moment developer develop the code, right? How we can take the code, build the code, deploy the code into Kubernetes. Again, using ArgoCD, how we can do that, and again, how we can monitor the applications and Kubernetes clusters, and how we can collect the logs by installing this monitoring tools, logging tools. Also, we'll try to understand end to end again. So here again, like we will understand all these tools individually, and also we will try to integrate all these tools together. So we are going to write a pipelines. We are going to write a pipelines. Like by end of this training, you will be having the in detail knowledge about all these DevOps tools that is widely used in the market. So you can easily compete with any person who is already working in DevOps and cloud for last 4 or 5 years. That much extent we are going to cover. That's why this training is taking almost 6.5 months, 6.5 months, because here it is not like what is what. We will be focusing theoretically, we will be focusing practically, everything. And also we are going to write a pipelines, we are going to write a infrastructure like this. Like at the end of this training, you will be easily able to understand how to write a Docker files, and at the end of this training you can easily able to understand how to write a Jenkins pipelines, like these type of complex pipelines also with the different stages, how you can build and deploy applications in Kubernetes also, right, via pipelines, and how we can use a GitOps model, GitOps way of doing the delivery using ArgoCD also you can understand. And again, how you can write the Terraform code. Suppose at the end of this training, again you can understand how to write the Terraform code for complex resources. Suppose in Terraform also you can understand various concepts. What is Terraform block? What is remote backend? Right? How to create resources? What is data sources? What is variables? And how to create a lot of advanced things, like how to create a VPCs, subnets, again route tables, IAM roles, EKS clusters, NAT gateways. So all these complex script also, Terraform scripts also you can understand. And again, instead of manually executing these Terraform scripts also via Jenkins, how you can execute these Terraform scripts also via pipelines. This type of complex pipelines also you will understand. But it takes time, it takes dedication, it takes effort. So here, so many people has a lot of interest and enthusiasm in the beginning, but the same commitment, same enthusiasm, same dedication, effort you have to keep for complete 6.5 months. Then only you can become an expert. Then only you can become a subject matter expert, and you can easily manage the interviews. You can easily manage the work. And again, along with this, we can use AI assistance, AI help. Suppose instead of manually writing these type of automation scripts also, you can use a chat GPT, you can use GitHub Copilot, AI assistance, AI assisted DevOps. So using GitHub Copilot or using chat GPT, how you can you know, get this type of code developed. And again, if there are some issues or bugs, if you just give the logs, if you just give the logs to the chat GPT, it will analyze and it will give the possible issues also, that prompting. So here and there, small AI tools also we will use, but this is not a AI ops. We are not focusing on AI ops and ML ops, but that AI ops and ML ops also similar to the DevOps, similar to the DevOps, but that is a AI based application, AI based applications, right? The way we are going to build and release normal web applications, normal API based applications, microservices, AI apps is nothing but the AI agents has to be built, AI agents has to be trained, AI agents has to be deployed automatically. That is AI apps. But if you wanted to become a AI ops engineer or ML ops engineer, you need to learn Python along with this, and you need to learn some other tools, AI related tools, data pipelines, data pipelines related stuff also. But that AI ops is different, AI assisted DevOps is different. So here we are using AI assistance to improve the productivity in writing some automation code, writing some kind of a Terraform code, and again analyzing the logs also. We can use some kind of a prompting, all those things, right? So this is the agenda, right? And along with this, we have a resume preparation sessions also, right? So here the course features. So as I already said, we will be having 2 years of access to the recordings, 2 years of access to the recordings from batch start date. Suppose today August 1st 2026, so till July 31st 2028, till July 31st 2028, you will have access to the recordings, 2 years access to the recordings. Anytime you can go through and practice. And again, each and every topic will be provided with soft copy materials. And again, here we will be giving some kind of an assignments also when we are you know explaining something, and we'll take some kind of a sample applications and projects we will cover with the use cases and scenarios. And again, topic wise interview questions will be given. And if you are stuck somewhere, right, I will be assisting you with the debugging and troubleshooting also. When you are practicing something, if you stuck anytime, you can post your issues, your queries in the group, or you can contact me also, I can help you, right? So here, why RushiTechnologies? Why not others, right? So here you can, most of you guys are joining or referred by someone who already trained from me, or who are already working in some companies. So I am into trainings from almost last 10 years, and like most of the people already working in different companies, you know the feedback about my trainings. If required, you can check the content which is already available in my YouTube channel. Like I have provided some advanced videos also. If you go through these videos also, you will get an idea how my teaching will be and how depth I will be covering also. And here you can see like the feedback, and
You don't need to
feedback
be a
about trainings, feedback about my sessions also from previous students also here, right? And here I will be providing a training from very basics to full advanced level. Each and every topic will be theoretically explained and practically again discussed and implemented, right? As I already said, you may have a lot of common questions, like there will be a 2 years access to the recordings from batch started. Recordings are non-downloadable, no downloading access, but you can like watch. But if you find anyone is misusing these recordings, anyone is misusing these recordings, we will immediately terminate your admission. We will remove your access also. Don't misuse your recordings again. So soft copy materials and running notes will be provided. You will have a lifetime access. In a detailed way, there is a soft copy material that you can download and you can keep it for lifetime. So here fee is refundable? No. Once you pay the fee, it's non-refundable. So before you pay the fee, make your mind and make sure you pay the fee. Once you have decided, once the fee is paid, it is non-refundable, non-transferable. And we are not doing any proxy support. People say, sir, we need an interview proxy support. We hate that proxy, right? In the training itself, we are going to focus more, right? The training itself is like a detailed way. We are going to discuss real-time use cases, scenarios, and projects. If you attend the training, you can easily manage your work and you can easily crack the interview. If you see recently also previous batch students, this guy, previous batch student, actually he got fired in some company due to recession, but he was immediately get into the job with this training, right? Similarly, you can see there are a lot of people who continuously attending the sessions. They were able to manage the interviews, they were able to crack the interviews also. This person actually in the recent batch, the batch is still going on. The batch is still going on, but he was already working, but he lost the job recently, and again he got into the job after this training. Right? So the training will be in a detailed way, but only thing you need to also keep lot of efforts from your side. If you follow my instructions, if you follow the materials, if you follow the sessions, right, you will also become a subject matter expert. Right? So that's it from my side, right? So as I already said, the regular sessions will start from August 3rd. August 3rd, morning 6:30 to 8:15 a.m. IST. The classes will be Monday to Friday, first 1 month. First 1 month, Monday to Friday. But after that, Monday to Saturday also will be there. Monday to Saturday. Sunday holiday. Monday to Saturday also will be there after 1 month. But initially, first 1 month, we will be having Saturday also break because so many people might be new to DevOps tools. It may take initially to get adjusted. After that, Monday to Saturday will be there. So here, if you wanted to make the payment and if you wanted to enroll for the regular sessions, you can reach out to me on this number. This is my personal number, and you can reach out to other number also. This is a institute number, but both I am only handling. You can reach out to me, this number or maybe this number for making the payments or for enrolling for the regular classes, right? So the regular classes will start from August 3rd, that is Monday, right? So that's it from my side. I am giving the permissions for unmuting yourself, and if you have any specific doubts, any specific queries, you can unmute yourself and you can ask one after the other. Just a minute. Yes. Now you guys can unmute yourself. If you have any doubts, any questions, any queries, let me know.
Yeah, hello, sir. This is Kiran from here.
Yeah, Kiran.
So, yeah, sir. This all class will be taken by your side only, or like from one topic
No,
will
no, no.
taken from different institutes?
No, in RushiTechnologies, I am the only trainer. There is no other trainer. I am only the trainer, and I am only the admin team here. And no one else is working for me. I am only doing everything, like classes also. I am only handling all these tools, all these technologies.
Okay, okay. Sir.
Any other questions? Any other
Yeah,
queries?
yeah, sir. I have one. Sorry to interrupt. I have another question. So, sir, actually, we are working in our company, like we are working rotational shifts, right? So sometimes we are unable to join the live classes. So we can use the recording, and then next classes we can ask our doubts and everything, right?
Yes, yes, yes. So here, right, each and every session, we are going to have 1 hour 45 minutes. And again, if you have any doubts, any specific questions, we can extend another 15 minutes also till 8:30. Also, I can spend some time, and in the live session, at the end of the session, you can ask any doubt, any questions, any queries if you have.
Okay, got it. Thanks.
So for everyone, I will help you how you can create an AWS account, right? So here, uh, in the next session, I will try to explain. We are going to use AWS free tier account. I will help you how you guys can create an account in AWS yourself for free tier. So AWS is giving a free tier account for 6 months with $100 credits, right? So I will help you in the next session how you can create an account, and everyone will be having their own AWS account. So we will be practicing directly there.
Yeah. Hi, Balaji. Do
Yes.
you have any sessions like multi-cloud, any other training programs in your institute?
No, multi-cloud, no. Actually, this DevOps tools, DevOps concepts remain same. Uh,
Okay.
this Jenkins, Docker, Kubernetes, GitHub Actions, Maven, Ansible, Terraform, everything same. Only thing
Okay.
is the cloud platform will change. Here we are using AWS platform where we are going to create a required servers, required storage, required networks, required database clusters, Kubernetes cluster to run the application. But in other cloud, the tools is same. But the only thing is instead of AWS services, people may use Azure services, GCP services. But this DevOps tools, DevOps workflow, DevOps concepts remain same. And again, once you know AWS cloud, learning or working with other cloud also becomes easy. You can do self-learning because concept is same. The service names, the way we create is different, but the concept same.
Yeah. Okay. Yeah. Thank you, Balaji.
So Ayush is asking, sir, I have a 3 years experience as Java developer. Definitely, after this training, since you are already from development background, this DevOps is much more easier than development, DevOps and cloud. You can easily completely transit your career into DevOps also. Even I was a developer, Java developer, when I transit to the DevOps and cloud, right? So many testers, so many testing DBA people, testing people also migrated to DevOps with this training. So that much extensive we are going to cover.
Hi Balaji, this is Vinith here.
Yeah, hi Vinith.
So Balaji, I have a doubt like for practicing the DevOps tools, those tools are like paid only, right? So we won't get any free tires. So how we will be able to practice with that DevOps
No,
tools?
no. These all are free only. I mean to say, this Terraform is also free, open source and free. Basically, all these tools are free. Only AWS Cloud is chargeable. But again, for learning purpose, practicing purpose, AWS when we create an account, they are providing a 6 months free tier account with $100 credit. So they will give $100 in our account, and they will start charging from day one. But we are going to use that $100 credits within 6 months. You can install these tools on that servers, and we can practice. So here nothing is paid. You no need to pay anything from your hand.
Okay, Balaji, thank you.
Hello, Balaji sir. This is Sampath.
Yes, Sampath.
Sir, I just have one query for this Kubernetes.
Mhm.
Now we are having these tools like ArgoCD and Red Hat OpenShift.
Mhm.
So sir, in that training will also be given.
OpenShift is different.
Uh,
OpenShift is different, and ArgoCD is different actually. So we are
okay.
covering ArgoCD. ArgoCD to deploy the applications in Kubernetes and GitOps model. We are going to cover. OpenShift is similar to the Kubernetes, like alternative to the Kubernetes. OpenShift is from Red Hat company, but it's a paid enterprise software. So OpenShift is again built on top of Kubernetes only. Under the hood, it's Kubernetes, but some additional security features embedded by Red Hat company into the OpenShift. but there are also pods, deployment services, config maps, same, but it's a paid from Red Hat with additional security features embedded.
Okay. Okay, sir. Thank you.
So if you are from DBA background, not sure how this program can help you. So if you are from DBA background, if you wanted to migrate to the DevOps and cloud, this program will help you. But if you are still wanted to continue as a DBA, right, here this will help you with some kind of an automation. Even though you are a DBA, you should have good knowledge in Linux. Definitely, whether you are a DBA also, you need to be good in Linux, because when we are working with the databases, you may need to configure the databases, you may need to set up the databases, database clusters, database replication in Linux systems. So this may help you with the Linux. Maybe this training you can get Linux knowledge, Linux concepts, and shell scripting. You can write a shell scripts to take the backups of databases by writing the commands. And again, maybe you can take CA, I mean to say Jenkins pipelines to automate some database activities also, if you have wanted to still continue in DBA. But if you wanted to completely migrate to the DevOps and cloud, a lot of things will help you here. And again, suppose if you want, you can run your databases also as a containers using Docker, using Kubernetes. Suppose if you know Docker and Kubernetes, you can run your database also as a containers, so you can understand that stuff also. So some tools will help you in DBA role also here. But if you wanted to migrate to the DevOps, this is all these tools also will help you. Wanted to migrate from DBA to DevOps and cloud also, this will help.
Yeah, hey sir. So I'm from programming background. So this whatever the course is offering, like a different areas, right? Like pipeline and the infra. So
Mhm.
this all things will is related to like a program background, or it's like as I worked with some of the projects. So there we have several teams like infra and the security and the firewall maintenance and
Mhm.
the pipeline development. So these are several teams we have. So we all need to consider all the things, or specific things we can consider.
Actually, nowadays, you know, the market expectation, right? So the companies are expecting so many tools, but once you get into the project, again they are going to assign only some part of that work, as you already said, right? So again,
Mm.
you should know networking, you should know CI/CD, you should know containers, deployments, monitoring, all these things. But when they hire, they may ask so many things, but when you get into the project, you will be part of specific team again. But at least to reach that level, to get into the job, you should first focus on all these things. Later, if you are as part of your specific role, you can use specific tools again. But here, it is not like a complete coding knowledge is required here. Scripting like Jenkins groovy scripting, and Python, sorry, this Terraform, like HCL syntax. But we will be covering that HCL syntax, how to write the Terraform scripts, how to define groovy scripts, Jenkins scripts also. From basics we'll try to focus, but it is not like a complete coding level of script, knowledge is not really required here.
Okay. So, and one more query, like, so I actually have signed up my account, and it's my personal query actually. So
Mhm.
I actually exhausted some more amount, like it was, I opened some, I created some S3 bucket and it was opened for the last 1 week. It was charged
Mhm.
huge. So that will be costed, it's around $900. So how it will
Mhm.
be, sir? It's a free tier account.
No, actually, unless until you upgrade your account, it will not be upgraded. Maybe you might have, maybe by mistake, maybe AWS might have been populated. You have exhausted the free tier credits. You wanted to upgrade your plan. You might have clicked that. Unless until you upgrade, right, they will not
Mm.
start charging you. Okay. Maybe what you can do, you can leave that account completely. You can
Okay.
terminate that account completely. You can create
Okay.
another account. You can create another account again with a different mail ID, a different card. That card also should be unique. The credit card or
Yeah,
a
yeah.
debit card which you are going to use. If you are already used one card, same card cannot be used one more time again.
Mm-hmm.
So you can create, you can use another card again. You will get another 6 months.
Okay, so that charge and all will not be matter, right?
Not matter, but better you disable auto pay. If you have enabled auto pay option in your card, I mean to say here in the AWS, right?
No, it's a
Better you disable.
debit card only I have used.
Yeah.
So it's like so even I raised the query like I unintentionally it was happened like I raised a service ticket.
Yes,
Let's
sir.
see.
Yeah.
Yeah, thank you, sir.
Yeah, actually, the charges will be little more.
Mm-hmm.
Even I can't use a free tier account for every batch, right? So I am using
Yeah.
paid only. But for
Okay.
me, I am okay. I am
Mm-hmm.
paying some charges, right?
Mm-hmm.
Since I am handling multiple batches, also I am creating so many servers, so many systems. Monthly, I am getting bill.
Mm-hmm.
Sometimes I will get 15,000. Sometimes I will get 20,000 also.
Yeah.
Sometimes when I am explaining basics concepts, that time very less charge. So fine, but you guys can manage with free tier account.
Yeah, it's
So this
only charged for more on this S3 bucket
yes,
only. The
not
remaining,
S3. Maybe you might have done something else.
yeah,
Okay,
yeah, I have uploaded some data.
huge files you might have uploaded in S3.
Yeah, yeah. While exploring, I did some changes. Yeah.
Yeah. So in my this is my account, but it's paid account for you guys. Here it will show it's credits. It will show like how much credit is left like that.
Yeah.
But this is the paid account. But here you can explore your bills, how much it is billed. For me, I think last month I have used so many resources. So like I was explaining Kubernetes, I have a
Mhm.
EKS cluster running for last almost 20 days. EKS cluster running for last 20 days, and ECR, and also a lot of storage, uh, NAT gateways, elastic IP, so many things used for my last month. Almost $300 they have generated. But for you guys, this much will not go because I am handling multiple batches, morning one batch, evening batch, and again lot of servers for each batch I have created. So that is for you. But for you guys, within 6 months, $100 is sufficient. But again, if you exhaust that $100, maybe you can create one more AWS account with a different card and phone number.
Yeah. Yeah. Thank you, sir.
So can we get a cars for 2.5 to 3 years of experience? Santosh is asking. Yes, three plus and above, three plus and above, we have good opportunities there. But like 1 year, 1.5 year nowadays, less opportunities. So as part of this training, we are going to use AI assistance. AI assistance means like how we can use existing AI tools, existing AI softwares in writing some kind of a scripts, like that can be Terraform scripts, that can be answer, that maybe that can be Jenkins scripts also, and how you can use existing tools for analyzing some kind of issues or errors also. We'll try to use some little bit of AI tools like GitHub Copilot, ChatGPT, Cloud, all those things. Any other one has any other questions? Feel free to unmute and ask me anytime. Okay, if you have any questions that you wanted to discuss personally with me, you can reach out to me on this number. This is my personal number, right? You can reach out to me on this number. And if you have not yet subscribed our YouTube channel, kindly subscribe this YouTube channel, Rushi Technologies. so that here you already see so much demo sessions, and also some kind of a advanced topics also. You will, by going through these sessions, you can understand how depth my training will be and how my way of teaching will be here, right? If you have not yet subscribed, kindly subscribe this Rushi Technologies YouTube channel, right? And you can reach out to me on this number if you have any specific doubts, any specific questions, queries. And if you wanted to enroll for this training, don't rush last minute, because it's a early morning batch, right? If you call me or message me at the morning 6 o'clock on August 3rd, it will be very difficult to talk, because I will be going to start the session. So tomorrow, maybe you can reach out to me and you can make the payments, and you can do the enrollments, right? That's it for today. From here, I will continue with the regular session from Monday. If you have any doubts, any questions, any queries, reach out to me on this number. Thank you. That's it from my side. I hope you had a great time with me, and I hope you enjoyed the demo session. If you have any questions, feel free to reach out to me. Thank you. That's it from my side. We'll see you on Monday, guys.
Yeah, thank you.